Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you and your family in the best of health. Dear students, this lecture is for grade 7, boys and girls, both wings, subject science. And in this lecture, we will discuss the remaining topics of chapter number 9, which is about the dispersion of light. This is my 26th lecture, and I am your lecturer, Mrs. Saira Jamal. The first topic of discussion is about the optical fibers. What are optical fibers? Optical fibers are thin, transparent glass fibers in which light travels due to total internal reflection. You can see in this image thin fibers which are made up of glass and they are transparent, and in these optical fibers the light travels due to a phenomena which is called total internal reflection. About total internal reflection we discussed in our previous lectures. Critical angle of glass is 42, because if we are going to discuss the total internal reflection, so we must know about the critical angle, because total internal reflection takes place only when we say that when the angle of incidence is greater than critical angle, then what happened? Total internal reflection takes place, means that the ray bend in the same medium, and that bending of light in the same medium is called reflection. So the critical angle of glass is 42. It means that the incident ray must have an angle with normal greater than 42 degree. So an angle greater than 42 degree in these glass fibers will show the phenomena of total internal reflection. What is the benefit of this total internal reflection phenomena in optical fiber? The advantage or application is that this total internal reflection makes light transmission over long distances, which is possible only in optical fibers. So in optical fibers, the transmission of light to very long distances is possible. That's why nowadays we are using the optical fibers in communication, like in telephone transmission, in TV programs, and also in computers, due to its application, due to its advantage that that the light can transmit through a long distances in optical fibers. Optical fibers can carry thousands of phone calls at the same time. So like the problem in phone calls which we observed in our previous time, that is due to we are using the normal, like the metallic fibers for the transmission of electricity and transmission of light. But nowadays we are using optical fibers for this purpose, and the benefit is that even through uh, like optical fibers can carry thousands of phone calls at a time, and there will be no problem in signals or no problem in the calls. Then next topic is about the dispersion of light. Dispersion of light. What is dispersion of light? The splitting of white light, the splitting of white light into its component colors is called dispersion of light. It means that white light is composed of 7 different colors, and when the white light passes through a prism from rare medium to denser medium, due to refraction, the white light dispersed or split into its 7 different colors, which you can see here. This process is called dispersion of or splitting of white light into its component color after passing from rare medium to a denser medium is called dispersion. and this is called the band which we obtained after dispersion of light is called the spectrum. This is the spectrum of white light, which is composed of 7 different colors. Those 7 colors you can see, you can learn it by Webb Gaia. Webb, V for violet, I for indigo, B for blue, Gaia, G for green, Y for yellow, O for orange, and R for red. So Webb, VIB Webb, GYOR Gaia. You can you can memorize it by remembering this key. Webb Gaia will help you to learn these colors easily. So the splitting of white light into its component 7 different colors is called the splitting of light, and the band obtained is called this band, the light band, the 7 bands obtained is called the spectrum of white light. And by which phenomena the white disperse or split into its different components color? Refraction. Due to refraction, when the light passes from rare medium into the denser medium, it split into its component colors. So sunlight, you know, often is white. The light is white in color, although it is a combination of different color. White light or white color is not simple a single color. I told you that after passing that white light into prism, we can obtain the 7 colors. It means that we can see these colors in a rainbow after rainfall, and in sunny day, what happened? You can see the rainbow. These colors are red, orange, yellow, green, blue, indigo, and violet. So you can see in this image also the splitting of white light. The white light when passed through a prism, a prism is a glass, triangular glass or glass slab. When white light passes through the prism, what happened? You can see it split into its 7 colors or its component color. And this process is called dispersion of light. The splitting of white light into its component color or into 7 different colors is called, these are the 7 colors, okay, not other colors. These 7 colors combine together and form white color. So don't consider any other color except these colors because these are fixed. Red, I told you, Webb Gaia, Webb, violet, indigo, blue, green, yellow, orange, and red. So Webb Gaia will make the white light. Why does white light get dispersed? Why the dispersion of white light takes place? So when a beam of light enters a prism, all the colors of white light refract, because I told you that the splitting of white light or dispersion of white light into its 7 color is due to a phenomena called refraction. You can see white light when passes from rare medium into denser medium in glass. So it diffraction takes place, and due to the refraction, because each color is making different angle with the normal, you know that this is the surface of prism, and when the light falls on a surface, this surface, we will draw an imaginary line which is perpendicular to the surface is the normal. So this is our normal, and you can see each color is making a different color, a different angle with this normal. Angle of red color will be different than of orange color, then yellow, then green, then blue, then violet, then indigo. All the colors are making different, these reflected rays are making different angle with the normal. They are making different angle with the normal. So which color is making the biggest angle? You can see that the biggest angle is of the violet color. Violet color is making biggest angle with the normal, while red is making smallest angle with the normal. So bending of violet color is maximum, it bends more, while the bending of red color is the least, it bends the least. And this bending is totally depending upon the wavelength of light, because each color has its specific wavelength. So the wavelength of violet color is the least or smallest wavelength, and red color has the highest wavelength. So due to the highest wavelength, the bending of red color is least, and due to the smallest wavelength, the bending of violet color is maximum or more. When a beam of light enters a prism, all the colors of white light refract at different angles, and it causes the white light to split into its component colors. Red light bends the least, as I told you, due to its greater wavelength, it bends the least. Violet light bends the most and refract by the largest angle. I told you it is making, this is normal, and with the normal, white light is making the maximum angle. Let me see. It is making the maximum angle with the normal light. The red one is making least angle, and the violet is making a big angle or maximum angle with the normal. So in this way, white light disperses into its component colors. When this spectrum is again passed, white light passes to a prism due to the reflection, the light color or the component color will disperse or split into 7 colors. And when we pass this spectrum of 7, because I told you that the band of 7 color is called spectrum. When this spectrum is passed through another prism, you can see it will give us back the white color, because it is passing when the band of light passes from rare medium to denser medium, and then from denser into the rare medium, it will give us back the white color, which is the recombined form of these 7 colors. So this is how we get the dispersion of light, or white light dispersed into its component colors. Activity to understand the dispersion of light, which is activity 9.3, obtaining a spectrum of colors. For this activity, you will need a prism and a white cardboard. A prism and white cardboard. Procedure is that shine a narrow beam of sunlight, white light, sunlight, or any ordinary tube light or bulb. So since shine a narrow beam of sunlight on one rectangular surface of a prism, I told you that these are the rectangles in a prism. One rectangle, this is the rectangle. This is also a rectangular surface. So when the white light shine on any of the rectangular surface of a prism, or it falls on a prism in such a way that the spectrum of colors form on a white cardboard screen on the other side of the prism. You can see that suppose if there we keep a white cardboard, on that white cardboard we can see the 7 colors very easily. That white cardboard will act as a screen. So the white light, after passing through the prism, will refraction will takes place, and due to refraction, the white light will disperse into 7 colors. Those 7 colors, as we will keep the cardboard in front of that prism, and that cardboard will act as a screen. So when that dispersion of light falls on the screen, we will see 7 different colors. I told you, web gyre, violet, indigo, blue, green, yellow, orange, and red color. We can get these 7 different colors by passing the white light to a prism. So this is just a very simple activity to see the spectrum of white light. This 7 color band I told you is called spectrum. This 7 colors band, because this is a band of 7 colors, and this band is called spectrum, and the splitting of white light into this band or into this 7 different color is called dispersion. Identify the colors of light seen by you, which color is at the top and which one is at the bottom. So if you see the spectrum, you can see the red color is at the top, and the violet color is at the bottom. And I told you the reason of bending of violet color more and least bending by the red color is due to its wavelength. Red color wavelength is greater than the wavelength of indigo color. So lesser the wavelength, more will be the bending of light, or greater will be the frequency. And smaller the wavelength, greater will be the frequency or bending, and greater the wavelength, lesser will be the frequency or bending. Activity 9.4, white light is a combination of 7 colors, as we discussed in our previous slides, that white light is a combination of 7 colors. And for this activity, you will need a cardboard, glazed papers of different colors, and a string. You can see a string or a wire. Procedure is that take a round cardboard, paste equal size pieces of glazed paper. You can see this is a round cardboard, and place pieces of glazed paper on this circular or round cardboard. Then make two holes near the center of the cardboard. Make a loop of a string through these holes. Make two holes at the sides, and then tie the string on it through these holes. Hold the two ends of the loop into your hand and also twist the string strongly. Let loose the string and stretch your hand in and out alternately. What will happen? Repeat this again and again. The cardboard will start revolving. It will move. It will revolve in circular form, like it will revolve like in this form. And then the cardboard will start revolving as shown in figure. Watch carefully the revolving cardboard. So due to the revolution, what will happen? Can you still see the different colors on the cardboard? No, actually due to the revolution, the color will mix together, and after mixing, we will not be able to identify a specific color. So this is actually the mixing of the different colors to give us one color, that is the white color. So we will see only white color. The reason is that after revolution or revolving of these different colors, they will combine together or mix together. After combination, we will see only white color. We will not be able to see the different colors on the cardboard. Even if you are not using strings, so you can use the even electricity for the rotation by applying a battery and by connecting this cardboard with the electrical wires, and then connecting with the battery, you will see this rotation of the cardboard. It means you can make a model of it. For making model, again you need the cardboard, round cardboard, and then different colors, especially the seven colors which the white light is composed of. The 7 colors of glass paper, cut them, paste them on the cardboard, and then at the back side connect this cardboard with electrical wires and then with battery. And when you connect the wire with the battery, what will happen? The cardboard will start rotation or moving. After rotation or revolving, we will not be able to see these 7 colors because they will combine together and will give us white. So we will see only white color, no different color. So this is again due to the remixing or combination of the white light. Which color can you see in the revolving cardboard? Only white color. Rainbow formation. Rainbow formation, as you know, I told you about the 7 colors. Actually, a rainbow is a natural demonstration of the refraction of white light, and dispersion and total internal refraction of light. All these phenomena. Rainbow is formed by refraction, dispersion, and also total internal reflection. All these three phenomena are over there. So you can see that when white light of the sun, this is sun, and when the white light of the sun falls on the water droplets, raindrops, when they fall on the water droplets, so these water droplets actually acts as a prism. These water droplets will act as a prism. So what will happen? The white light will disperse into 7 different colors, and it's in its component color. That's why our eye observe the 7 colors or the rainbow in sky. when the white light of the sun falls on the water droplets or rain droplets, the rain droplet actually act as a or serve as a prism. Then refraction will take place, and due to the refraction, dispersion, and total internal reflection, it will give us the 7 colors, and our eye will observe the rainbow. You can see here the rainbow also. This rainbow is observed by our eye. So when the white light of the sun passes through tiny rain droplets suspended in air, because you know after rain falls, water vapors are present in air, and those water vapor then will act as a uh, prism and will help in the dispersion of white light. So the rainbow is formed from light that bounces from droplets and then enter into our eye. Tiny raindrops suspended after rainfall, a rainbow may appear. Raindrops in the air act like tiny prisms. They refract and reflect the sunlight and then separate it into different colors. So after refraction and then reflection, the light separated into 7 different colors. The color scheme from the sun of rainbow is the same as in the raindrop spectrum made by the prism. Same Weber means red color band the least due to its greater wavelength, and violet color band the most due to its smaller wavelength from its original path. So in the rainbow, the red color appears at the top and the violet color appears at the bottom. Means the splitting of white light into its 7 colors is same if it takes place through a prism or through the rain droplets. It remains same. Do you know we can only see a rainbow in front of us when the sun is shining behind us? A rainbow usually shows all the 7 colors of white light. It means that rainbow will form only when there are raindrops in sky, in air, and also sunlight is important. No sunlight means no rainbow formation. So for the rainbow formation, droplets of air, water droplets in air, and sun is compulsory, sunlight. Then rainbow will form. Extend your thinking. Why don't we see a rainbow during most rain storms? I told you the reason that to see a rainbow, we need the rain, water droplets or rain droplets, and we need sunlight, and we need the appropriate angles of incidence of the light and for reflection and reflection to our eyes. Uh, Refraction will takes place when the light passes from the air into the water droplet. That is refraction. But after refraction, when the 7 colors uh, comes out from the raindrop, which act as a prism, then they will reflect it in our eyes. They will come in our eyes through a phenomena called reflection, because in air is the same medium for the white light and also for the 7 colors when they emerge out or comes out from the water droplet. Then reflection will take place. So through reflection, the light and the 7 colors enter in our eyes. If the raindrops are shaded by clouds or covered by the clouds, then the sunlight will not be, it won't be fall on the water droplets, and then in turn no rainbow will form. So for the formation of rainbow, important things are, or the requirements are rain, and then sunlight, and then the falling of sunlight with a specific angle on the raindrops. If I told you the raindrops will covered by the clouds, then sunlight will not be fall on the raindrops properly, and then no formation of rainbow. Activity 9.5, you will need a sunny day and a running hose pipe, water pipe, because I told you water will act as a, or will serve as a prism. So stand with your back to the sun, just stay here and your back will be toward the sun. Then spray water from the hose pipe. From place your thumb over the hole of the pipe and make a spray of it. So when the sunlight will fall on the spray of light, the spray of water will act as a prism because it has water in it, or water molecules. Those water molecules will act as a prism. So watch the spray against a dark background, grass or wall. You will see that a rainbow over there, because can you see a rainbow in the water? Droplets of the sprinkling water. What is the order of these color from bottom to the top? Yes, you will see the when the sunlight will fall on the water of the pipe, the water in pipe, or will the water molecule will act as a prism, and it will give us the rainbow. And the pattern of colors are same. Red will be at the top and violet at um, the bottom. The pattern is same, no change in pattern. Then next topic is about the colors of light. As I told you that there are 7 colors of white light. So an understanding of color is very useful in photography and theater lighting. People who work with lights of different color, they must know how to produce lights of various colors from a few basic colors. So the colors that can be used to make other colors are called primary colors, and the other colors which are formed from mixing of these primary colors are called the secondary colors. Primary colors and secondary colors, like red and blue and green, these three are primary colors. When we mix red, blue and green color, it will give us white color. So white is secondary color, and this red, blue and green are the primary colors. The painters, they are mostly use or make colors by mixing the primary colors, and then they make a color of their requirement or the desired color. When two primary color mix, they produce a secondary color. Cyan, yellow, magenta, they are secondary color. A color television uses different combination of colors, like red and green. After when you mix red and green color, it will give us the yellow color. You can see by mixing red and green color, we will get the yellow color. Mixing red and green will give us yellow color. Then mixing red and blue. Mixing red and blue. Uh, this one is mixing red and blue will give us the cyan color, and by mixing red, blue and green, by mixing red, blue and green, it will give us white color. Okay, I mistakenly mentioned here magenta. Magenta is formed by mixing red and blue. By mixing red and blue will give us magenta. This is magenta, not cyan. Okay, by mixing red and blue will give us magenta color, and by mixing green and blue will give us cyan color, and by mixing all three colors will give us white color. Mixing red and green, it will give yellow color. Red and blue mixing will magenta color, and green and blue will give us cyan color. And mixing all the three color will give us white color. As I mentioned here, red, blue, green will give us white, not magenta. I mistakenly mentioned here magenta. We can obtain other colors of light by mixing lights of primary and secondary color. By mixing these colors, primary and secondary colors, you can get the desired colors or the color which you require or desire. So this was all about the dispersion of light, rainbow formation, how rainbow is formed, and what is the color pattern in rainbow, and um, what are the colors of light, how can we get the secondary colors by mixing the primary colors. So this was all about um, the dispersion of light. The remaining topics, inshallah, we will discuss in our next lecture. Till then, take care. Allah.